All right, Unit 8, Lesson 1, I'm taking a look at question number 2 and 3 here. So we need to find the area and perimeter for question number 2, and I'm going to start with calculating the area. And so in this shape, it's kind of an odd shape, so I'm going to divide it into two shapes that I know how to find the area of. And so I know how to find the area of this rectangle on the bottom, and really that's pretty easy because I could just count the number of boxes. And so it's 4 units squared there. And then I can find the area of the triangle. The area of the triangle is 1/2 base times height. And so the base in this case would be 1, 2, 3, 4. And you could use this as the height, which is 2. So it's 1/2 of 4 times 2 to get the area of the triangle. And once you have that, you'll add it to the 4 units squared to get the total area. So your total area is going to be the 4 plus your answer from up there. Okay, and then to find the perimeter, we're just adding up all the sides. So when I find the perimeter, I'm going to count 1 plus 4 plus 1, 1 plus 4 plus 1, and then I need to find the length of these two sides. To find the length of those two sides, since they're kind of slanted lines, I'm going to use the Pythagorean theorem. So I'm going to draw in a right triangle here, and this is going to be C in my right triangle, and A and B are interchangeable, and in this case it's an isosceles right triangle, and so A is 2 and B is 2, and so when I do the Pythagorean theorem, to get the other side, I'm going to do 2 squared plus 2 squared equals C squared. So 4 plus 4 equals C squared. 8 equals C squared. And so C then equals the square root of 8. And so when I go back up to find the perimeter, I know that C is the square root of 8, and this side over here is the same, so the square root of 8 again. So when I find the perimeter, I'm going to add in 1 plus 4 plus 1 plus the square root of 8 plus the square root of 8. And so to calculate the total perimeter, you're going to combine like terms there, knowing that the square root of 8 and the square root of 8 can't be combined with that 1 plus 4 plus 4. Those are two different terms. Okay, so that's number 2. The next thing we're going to do is look at number 3, so I'm just going to scroll this up a little bit. So for number 3, we're going to start out by plotting some points, and the points are 0, 0 for O, and then A is 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and B is 4, 1. Okay, so we're going to, sorry, I can't use a straight edge on here, so it's a little messy. It says find the area of the triangle with the vertices listed. And since all of these sides are slanted, there's no easy way to find a base and a height. So we learned a strategy in class today, which was kind of boxing in the shape. So I'm going to box it in by drawing a rectangle that goes up over to A, all the way down and over back to O. And I'm going to try to find the area of the whole rectangle. So the area of the rectangle has dimensions 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 1, 2, 3, 4, 5. And so that's 6 by 5, which is 30. Now I'm going to subtract off the triangles to be left with just kind of the red triangle that I started with. Now I've got one little unit there that I will keep by itself. So I will calculate the area of these 3 triangles. So the area of this one here would be 1/2 area of, let's say this is triangle 1. So the area of triangle 1 is 1/2 of 6 times 5. Let's do area of triangle 2. I'm going to call that triangle 2. And that has dimensions 1, 2, 3, 4 by 1. So 1/2 of 4 by 1. Let's do, area of triangle 3. I'm going to call this one triangle 3. 1, 2, 3, 4, 5 by 1. So 1/2 of 5 by 1. So you're going to get 3 areas of triangles here. And then we've got this other one, this little 1 unit here, 1 little square. So you're going to get these 3 areas and plus the 1 other unit and subtract that away from the 30. So 30 minus the blue areas will give you your total area for this red triangle that we started with. That's it.